see if this works. Hey, everybody. Those lights are really bright. Anyways, so yeah, so I started working for my first SP when I was about 16, and I'm not, 35 now, so that was quite some time ago, back in the dial-up days. But these days I focus mostly at Cisco on network architectures. I'll talk a little bit about what we call Agile Services networking, and then how we apply some automation tools we have at Cisco, like NSO, like Cross Workflow Manager, like CNC, to better automate those networks, because automation is a key part of what we're doing in terms of network architecture. So those that haven't seen it, we did do this launch at Cisco Live back in February for something we call Agile Services networking. If you're familiar with something we call a convergency and transport for the last 4 or 5 years, this is really an evolution of that. I think like the term SDN is not as popular anymore, so we had to create a new name, but the idea is to respin these, what we call validated designs, to cover new and emerging technologies. AI is, of course, one driver for this and how we build networks and simplify networks for the future. And that's kind of one key part when we look at these different building blocks for how we build these, call it service provider architectures, is simplification. There's a lot of different components to these architectures. So we take a lot of the best of breed Cisco, both the products and the hardware side, the automation side, as well as the technologies. And I won't cover those in any detail today because we have a brief amount of time. But foundational elements like on the infrastructure side, like coherent optics, are a big piece of what we do. If you look at like a routing control plane, obviously segment routing is kind of a foundational element of everything that we do today in building SP networks. So whether it's SRMPLS or SRv6. Again, that's a key component to it, but then also the automation components. In the past, I think that kind of got left behind a bit. Is we build these networks and we care about sort of the pipes and the control plane and how we control these networks, but then how we do automation is more and more important. And I know to the folks in this room, that's obviously something that you're more well versed in than a lot of the customers that I talk to, which are usually way behind on the curve as far as automating networks. Again, you guys are well ahead of where many people are today. So this is sort of the one overview. I'll call this more of a marketing slide that how we're approaching this and how we're building things. It's really about building single networks that can interconnect services no matter where they are on the network. The idea is to build like what we call a converged fabric. And fabric is also kind of a vague nebulous term that means different things to different people. To me, it kind of means this any-to-any connectivity, single networks that carry all of these different services. And obviously, key tenets of this are, as far as performance, simplification is something that we'll always mention within these architectures. Transport, and then resilience. So we build simpler networks. Simpler networks are usually easier to operate, but they can also be more resilient in how they're built. The idea is to really connect any service to any part of the network. So we kind of remove sort of centralization of services and how we terminate. And when I talk about services, we're talking about business services, like residential services, things like that. We can push those edges of the network deeper in the network as we evolve how we build these network architectures. But one kind of key part of this that we also try to focus on when we look at building these architectures, and these are things that we validate at Cisco. We don't just write the documents, but we do validate this and to make sure all these different components that we bring together work as one. But one big piece is sort of network lifecycle, and you'll see lots of different network lifecycle diagrams. This is my own, and maybe not something that's specific to Cisco or automation products. And there could be many more components to this. It really starts with how you build the network, how you plan the network, and then obviously how you deploy that infrastructure. So the infrastructure is sort of what we call more the day zero, day one configuration of the network, and how I choose specific hardware to deploy, how I connect that together, how I deploy that from both a configuration and sort of software lifecycle point of view. The infrastructure operations, that's the ongoing sort of maintenance of that underlying infrastructure. It's a very key part of the network that I think it gets overlooked. And again, folks in this room are a bit more advanced than others, but how we automate the sort of infrastructure automations is also kind of important, and how we simplify how we build these networks. And then obviously service deployment, service operation assurance is a key part that more people focus on. Like that's something that's sort of something you're doing every day in the network. So when we look at network automation, I think automating the tasks that are done more often is really the first step that most people take, and that's why service automation is always kind of key over some of these sort of infrastructure automation pieces. But when we look at lifecycle of networks, it's always continuous. The networks are always evolving, they're always being built or replaced. So none of these are kind of stagnant elements within the network. They're things that are always happening that we have to sort of focus on. And again, obviously we have products, and this is not sort of a product pitch slide, but these are the things that we incorporate as far as the design itself goes. And this is also not all inclusive of every product. I throw some things sort of under different buckets. You don't see NSO on here, but under what we call, C&C, there's definitely kind of an NSO there that's helping to automate the network, both from the infrastructure point of view as well as the services point of view, obviously. And we also use products like, Crosswork Workflow Manager to enact some of the changes we're doing in the network as well. So again, these are all different areas that we cover as far as the sort of the Crosswork family of products. And again, I'm not a Crosswork PLM, so I don't know all of the products and where they all fit. But within what we call Agile Services networking and building that architecture, these are kind of the focus areas that we have. And I kind of highlighted the infrastructure deployment because that's something I'll focus a bit more on than the others. So like, again, this is only a 30-minute talk. I could go through all of these different buckets and how we apply these to those, but we'll focus a bit more on just the IP infrastructure deployment piece and kind of the products and things that we're using to do that piece of it. One tool that we've, it's been sort of a new version. I think a lot of people are familiar with like Cisco Way and Cisco Way in the past. Crosswork planning is a new version of that. So we do this validation in our labs, and what you see here is kind of a portion of a validation lab that we have where we look at these solution architectures, we apply these products to them, and try to apply those to these sort of real-world network scenarios. So this is a case where we're using crosswork planning to do, we're consuming the data from that network, we're building things like demands across this network, and we're using that, the tools like crosswork planning to simulate network failures and see how that behaves. And there's kind of two parts of that. We're using that to exercise the product. Like I said, again, we use the products in our labs, and we do find bugs in those that we test. The idea is to exercise the products, but then also to be able to build networks in sort of a real-world scenario. So it takes using these products and operating them like an actual service provider would operate those networks. Again, I've been at Cisco about 8 years, but prior to that, I spent most of my career at service providers. So that's just one tool, and again, it's not a deep dive on crosswork planning. I know there's folks here that could give a lot more information about that specific product and all the pieces of that. But it's just to show, kind of in these scenarios and architectures, we're looking at these products to build those networks. And obviously, Crosswork Network Controller there's plenty of sessions on CNC and demos on and breakout sessions on CNC and using that for operations and networks. And again, we do the same thing with these validation labs. The lab that we build is call it an inter-domain network. So we try to simulate sort of real-world SP environment when we build these solution architectures. What you see here is just simply like it's an SRv6TE policy across this multi-domain network. And again, there's many other parts of the CNC we use. It's just kind of showing the networks we build that we use in the planning tools as well as CNC and the operations side. If there's any questions about how we use these or how we validate this, feel free to reach out to me. There's obviously an automation aspect to validation and test as well, and I won't talk about that here, but that is something we employ within our solution validation labs as well. I'll talk a little about network fabrics. It's a bit of a switch because this is a part that we focus on when we look at sort of Agile Services networks, and I mentioned the term fabrics and how we look at building networks and more of a fabric type approach. And I think when people think about fabrics, they think about flow fabrics, data center networks, very kind of topology rigid ways of building networks, and that is an idea of where we see fabrics and even service provider networks, depending on where that fabric's located within the network. But the idea with fabrics is devices like they have roles, they have responsibilities. We see a lot of service provider networks that are built kind of in an ad hoc, organic way, where services are maybe not defined on specific nodes. Services are typically terminated somewhere where it makes sense, or where it makes sense from a business sense at the point where that service is turned up. Like maybe a new customer comes along that has a 100 gig connection. I don't have a router that's typically a PE router, so maybe I'll put that connection on like a core router. So it does take some I'll say effort to build networks in sort of this I'll call it a fabric-like approach. But some of the key components of that are that every device has a role, and creating roles for devices obviously helps when we look at automating the networks and automating the deployment of those specific devices. Looking at not only in sort of a data center context, but also when we look at SP networks as well. So we look at like network fabrics. Obviously, I gave the example of a Clo fabric, which is very often seen in data centers, but we see those more and more often at the edge of service provider networks as well. When we're looking at more of a scale-out design for how we do edge service termination versus more centralized architectures. So we see a move away from, say, large chassis-based PEs that are maybe full rack devices into something that's more of leaf spine, where I have leaf devices that terminate various user services. So we think of that as a fabric, but then also something like an access ring type network or aggregation ring is definitely a fabric because it has a defined topology. It's a strictly deployed type of network where I have nodes that have east-west connections. I may have an aggregation at the top that looks a lot like a spine. So I can build and define networks that are more intent-based, based on these sort of topological constraints. But I just give this example as a fabric doesn't have to be a leaf spine fabric. It's more of this sort of any-to-any connectivity where nodes have defined constructs around how they're deployed, and then sort of their roles within the network. So we look at like Agile Services networking, and there's some construct we have within that architecture around what we call an edge fabric, and it is we consider more of a scale-out design for how different providers can terminate business services, residential services. So again, it's taking this notion of what may have been a large modular chassis in the past that was doing many functions as a PE and splitting that into it doesn't have to be fixed systems, but more of a leaf spine design on how I build that type of network. And it's just one topology option that we have within how we build things in like Agile Services networking. It's this type of architecture works for some providers. For some providers, it doesn't work, and for not all locations. Typically, if you're building a scale-out fabric, you have to have the services and the scale to support that. But for larger service providers or large locations where people are aggregating a lot of services, we see more tread towards this type of architecture, especially using things like fixed systems versus large modular chassis. And we will go into the pros and cons of that, but there's a lot of reasons for one versus the other. But again, and this shows some specific device types from Cisco we could use at different layers, but really kind of where we're going in the future of devices is to really be able to put any type of device at any layer of the network and be able to satisfy the needs of the services that are at that specific layer of the network. Another thing I always highlight with these sort of edge fabric diagrams is this sort of standards-based control plane. So we're not building something that's a clustering technology. The idea is not to make this whole fabric look like a single management IP or a single control plane IP. The idea is it's still using all standards sort of control plane-based protocols in order to do the interconnections. Because honestly, we see a lot of customers that not all the devices they have on the bottom are even the same vendor. So these fabrics could be mixed vendor. You could be using different spines and different leafs, but the idea is to build this in a more of a scale-out architecture. But how can we better automate that? So you look at a scale-out network architecture, like the first thing that you see is it's more devices. So when we do see this evolution or potential evolution of a provider from more centralized architectures or larger devices to these scale-out fabrics, the biggest thing that comes up is, these are obviously more devices that you have to manage. And again, we're talking about a clustering technology, so however many devices your line cards you may have had in a large chassis in the past, it becomes some, n times number of edge or leaf devices. So we have to have better ways to automate that. So how can we do that? So we can treat this sort of network fabric as sort of a single collection of nodes with different reduced management points, and that doesn't, isn't necessarily a management IP, but it's doing things like alarm correlation, how we aggregate that across the fabric. There may be some things we want to hide when we look at building these fabrics from an alarm point of view. Another thing we're looking at is how do we automate sort of the insertion and onboarding, and that gets to sort of that lifecycle management of the infrastructure. Like, how do I make it easier to build this? And we've seen this for a long time in data center networks, how using ZTP, using sort of automated onboarding of devices, but bringing that to what we do with sort of service provider networks as well. More advanced use cases we have are around things like traffic balancing or even automated service placement. So if I have multiple, say, leaf devices in an edge fabric that are solving the same service or terminating the same service, like L3 VPN across different nodes, can I automate how I select which node to put that on based on some type of service characteristics? So there's some of the other more advanced use cases that we're looking at from an automation perspective to help sort of enable the management of these fabrics in an easier way. So we look at, like I said, these are just a non-exhaustive list of sort of management tasks with fabrics. And when you look at this, it doesn't really differ much from what you see in any type of network. So obviously there's network automation tasks and management tasks that are needed. Are these all specific to fabrics? Not really. Most of these are applicable to all networks. But as we, it becomes a little bit more important as we increase the number of devices across the network, we have to kind of look more at these and make them, a critical part of like how we operate the network. So one is like defining a fabric. So the idea with a lot of these, network fabrics is to make them, intent-based. So we have a source of truth for how that fabric is defined, and then we onboard devices into that and insert them in specific roles, and then also have define sort of predefined connectivity for a fabric. And again, this is a lot of what's been done in the data center world for a long time, but we're kind of looking at that for more service provider networks. Obviously, device commissioning, how we bring up the fabric, and that comes to using tools like ZTP to do that, no matter what type of device it is, whether it's a spine or a leaf, or an access node in a ring. And then discovery of those devices and more automated discovery of that. So using tools like, potentially things like LLDP to do automated discovery of new nodes and onboarding those nodes without really kind of any human interaction. And obviously there's a long list of operations around software lifecycle, management of software, sort of the health and performance. And like I said, the advanced use cases are around, when we build these network fabrics, is to have intelligent software or intelligent service placement. And of course, obviously, visibility end-to-end of services. Obviously, a lot of talks about how we can get better insight into the services across the network as well as the infrastructure, and leveraging all those tools to make the network mostly simpler to operate and get more visibility into. And then things like coordinated maintenance. When I do build a scale-out fabric, there's a lot of redundancy built into that sort of network design. Being able to do maintenance and even correlate if I have a service that's dual home to two different nodes, the automation to basically do that maintenance on say one node and not the other, or not do them both at the same time, is kind of an important element. So what we've done, sort of, and what I'll show you now is it's not necessarily a Cisco product. These are kind of POC things we did to demonstrate how we could do sort of this fabric definitions and how we automate fabrics in a better way. And we're using two tools for that, Cross Workflow Manager, and then obviously NSO is a key part of how we've built some of these fabrics. And for a lot of folks here, this will probably be very basic NSO, but these are sort of some of the foundational sort of building blocks that we use in order to define these networks and define how they're built. And hopefully everybody can read this. But the idea is, we have this notion of fabric that we define in NSO. And we can have multiple fabrics, and fabrics can span more than one location. They can inspect, it's kind of a loosely defined topology constraint. But with a fabric, we always have things like roles. So we define roles within a fabric that are based on potentially a device type. but more often, based on what that device is doing. So any node that's onboarded into what we call a fabric has to have a defined node, and then obviously things like templates and variables. That's, I think, something I said very, very basic in NSO, but it's kind of a very critical part to being able to sort of automate and onboard nodes into the fabric without much human interaction. It's part of like something we'll look at a bit later. I kind of highlighted this is like fabrics have specific properties, and there's other properties here, but one is sort of a target OS version that you see under a specific role. So I have basically a device role. It's called XR Leaf that has a topology role, and then under that we have an OS version. So in this example, like an OS or an XR version is tied to a specific role. And that can be used later to check sort of the compliance of the devices that fit that role. And again, it's about automating tasks for multiple devices. Again, I mentioned as you build these fabrics, they're more of a scale-out design. You have more devices. So you want to try to do is more actions against, like, say, a role versus a specific device. So it's less enacting changes against like one device versus a fleet of devices. We often call things like fleet upgrades and fleet operations. But the idea is to have these sort of identifiers and these target characteristics in order to better identify what we need to upgrade based on the role of that device. So within this sort of simple fabric automation that we built, we have things like device definitions that are used for things like ZTP. So this allows us to basically automatically onboard devices into fabrics. And we could do that through ZTP and DHCP, or we could do it manually through onboarding a device into NSO first, and then basically then onboarding the device into the fabric, which is where we apply the various configurations that are needed. I don't think I have a slide on this. The other thing we also define more of an intent-based way is the connections between elements in a fabric. Like you mentioned, there's typically well-defined topologies versus east-west or leaf-spine relationships between devices and connections. So we look to sort of build those connections ahead of time, and that way we can use that to potentially check to make sure those are valid within like an operational sense. So the source of truth for those fabrics is going to be like in NSO, in what we build in these fabric definitions, as well as the sort of interconnections between elements. Within the device template, this is something very simple as far as defining device-specific variables. And obviously, you could fill this in via API or CLI, but the idea is to use these templates and drive variables specific to nodes for this. So I have a video, but I don't know exactly how to make this play. So we'll see if, I don't know, somebody else can. Oh, there we go. Yeah, so I'll kind of just talk through this like as it happens. So this is the workflow management piece of this. And for those that haven't seen Workflow Manager, this is in Crosswork Network Controller. But we have a lot of different workflows that we've created in order to drive the automation. And the purpose of using Crosswork Workflow Manager for this is to do this at scale. So this is a case where I showed those sort of device details. This is a workflow that populates those device details. And this is maybe kind of a simple example of using Workflow Manager and interfacing with NSO to do this. The idea is to drive this sort of more at scale across a number of devices. So all the components that we could do to populate how we build the fabric within NSO, we've built Crosswork Workflow Manager flows to do that. So in this case, I'm really just populating the same data that I was showing earlier, which is related to a specific device and that specific device's properties around the template variables and the role that that device is going to play in the rest of the network. Like I said, I think there's quite a bit more detail about Crosswork Workflow Manager that'll within the next few days. But obviously, this is NSO. I could see here that I've populated this device as I showed in the previous slide with all the various details around the device name, the serial number, things like that that drive kind of automated onboarding. So the next thing we we do typically is onboard the device into the fabric, and that's also something that we're using Workflow Manager to do, and you could do this just through NSO if you wanted to. But again, the idea is to drive more automation through these tools like CNC and these workflows. And then, like I said, again, in this case, we're doing this fairly manually, but you could drive this all via API if you wanted to. So what this does, it creates this specific device that's in our lab. It onboards that into the fabric. And this is a case where I'm not using ZTP to do this. During this demo, ZTP takes quite a bit of time. So the idea is we're onboarding the device into the fabric. It's a device that's already been onboarded into NSO, but this is applying all of the sort of day one configuration that's associated with that device in the fabric. So I can see here, I kind of have this show running config fabrics, and I now have the role, and then now I have a specific device that's part of the fabric. So I can have specific show commands to show exactly which device in the fabrics or belong to a specific fabric. And we can see that it has this specific role to that. And again, part of that role is looking at things like software versions. This is just showing the configuration that was applied to the device based on the templates that I defined for that role. So it's not device specific, it's more, there's specific elements that are part of a role as far as templates and variables, and there's device specific attributes that we've filled in based on the role and based on those specific attributes. And I don't know where. So again, we have all of these different workflows to do the different components within that. I think that was a part where I was looking at different connections. So again, when we build these fabrics, we can build fabric connections, and it's meant to be kind of an intent-based way to define the interfaces that interconnect different elements. So we can, in this simple automation, we can make those single-ended, we can make them dual-ended. In this case, this is sort of a single-ended connection. And we're just simply, inputting kind of where that connects as far as endpoints go. And again, there could be two endpoints that are used to create each connection. And that way I can validate that that's a proper connection later on against sort of operational data. But we run that task, and I think this one where it was taking more than a second to run. Usually these take only a fraction of a second. But we can see that's, that's done, and now I've populated that connection, and that when I populate that connection, it also pushes that configuration down to the device as well. So in this case, we could see how this is my input data into my workflow, which defines the interface, the address, and the endpoint. So if I look in NSO now, I can look within the fabric. I can see which connections are part of that fabric and how that's defined. And then I could also look at the device itself and see exactly the configuration that was applied to that interface that's in that now connected to that fabric. And sort of the last step that I'll show here is around, something that's probably a bit more interesting is around that OS compliance. So again, within the topology role, we define what the target software version was going to be. So we have additional automation that checks to see that the OS is compliant to what that role specified. So this is not checking anything specific to that device. It's checking kind of all devices within that fabric, and I could narrow that down to a specific role in the fabric. But the idea is to look at that specific version across and see all the devices that are sort of out of compliance within my the target version I defined for that role. So in this case, I can look at all devices, like I said, check against their target versions, find out which ones are not compliant, and then potentially act on that. So in this demo, we're not going to act on that. Upgrading an XR device takes quite some time. But we could kick off a job to do that as well. And in general, the workflows that I'm showing here, so you can see here, this device, the OS version is not compliant to the one we define for that specific role for that device. So again, these are all, some of these are sub-workflows. We have compound workflows that could go through the entire network and upgrade all the devices that are non-compliant. So that's sort of the real key with this and automating kind of that part of the lifecycle. Is being able to enact that against many different devices at the same time, and potentially devices across different even fabrics. So when I look at devices that are non-compliant across like a set of fabrics, I could choose to upgrade those all at one time in one workflow. I know most people may not trust things as much to do that, And the way we built this, like what's actually doing the upgrades could be automated as well. So we have a different NSO service with this proof of concept we've built that's performing all the upgrades, but that upgrade could be done through other tools like CNC's sort of fleet upgrade mechanism. So again, we're using sort of CWM to drive a lot of that automation in a way that's not bespoke to say NSO, or it gives us the ability to use different tools to drive different parts of the life cycle. With that, I think I am out of time, but if there's any questions, feel free to ask them or catch me afterwards.
All right, can we put up the Slido QR code again, please? There is one question about what's for lunch, and you'll be able to find out soon in the main area there. While we're waiting, if any questions come in.
I don't know anything about lunch, though.
Pardon?
I don't know anything about lunch.
No, well, it'll be a surprise.
Yes.
Sessions will start again at 1 p.m. local time here. The AI lab is Bank Fac 1, Bank Fac 1, and Bank Fac 2 is the breakouts, and then sessions back in here. Stream is one, and the AI lab is in 2. It's a very awkward room name. We should, for us English speakers. Yes. I think you're free to go, Phil, and
okay.
so are all of you.
You guys
lunch.
can have lunch now.
Thanks very much.
Okay.